In this project, we tackle the problem of novel view synthesis of 3D objects with few views. Consider these images and try to imagine the whole object in your mind. Try to think how we can easily understand the shape, color, and texture of the object just by looking at two views of a same object. Relying on the direct visual evidence in these images, we can easily identify that the apple is red, has a stem. Even more impressive is that we can imagine beyond the obvious to estimate the 3D model of the object. We can form a mental model of that object even though some parts are not observed. We are aiming to get this ability to models in our project. Humans rely heavily on their ability to perceive the 3D world. Machines struggle to do this. Injecting the world knowledge into machines is necessary to overcome this challenge. The problem we are tackling is novel view synthesis. It is the task of synthesizing a target image with an arbitrary target camera. The image will be synthesized using source images as the basis. There are several different ways to solve novel view synthesis in the literature. We focus on the method called neural radiance fields. Neural radiance fields are used to represent a 3D scene as a neural network. It takes a point in 3D space and a view direction and returns the color at that specific point. To generate a pixel in an image, the ray is passed starting from camera in the view direction towards that pixel. Then in the 3D space, coordinates that line in that ray is sampled and color and density at that point is obtained. These color and density is then integrated using volumetric rendering equation to get the final RGB color in that pixel. If we do that parallelly to all the pixels in the image, we can obtain the view image from that direction. But it still requires multiple views of the same scene to train it properly. It is time-consuming and doesn't share knowledge between scenes. Therefore, our problem becomes to obtain the novel views of an object from different viewpoints with few views. Since the nerds made the problem into a learning problem, we need to find efficient learning algorithms. Thus we go to meta-learning. What exactly is meta-learning? It is learning how to learn. When we train neural networks, we usually start from scratch with random weights. By employing better initialization techniques, we can help our model adapt quickly and efficiently, even with limited data. Meta-learning is like a talented student who learns to learn effectively and quickly masters multiple subjects with limited resources. By accumulating knowledge and learning strategies, they acquire powerful techniques to tackle new subjects effortlessly. Similarly, meta-learning equips neural networks with the ability to quickly learn. We propose a meta-learning-based approach to reduce the amount of images needed by NERFs. We find better initializations so that model can be easily adapted with few data and steps. We initialize the model with a random weight and adapt the model for a certain scene. We note the new optimal parameter for the scene. Then we train the model to second scene and so on. After obtaining the optimal parameter for each scene, we get the resultant vector and move the initialization in the direction of the resultant. We do this for several iterations to obtain best initialization for those categories. The inner loop denotes the adaptation step that happens for each scene. In the outer loop, we loop through each scene of that category. In the parameter space, we move the parameters towards the resultant to get the better initialization. We use a preprocessing pipeline to remove unwanted background information and to downsample the image to increase the speed of training. This shows the result of our pre-processing pipeline. We evaluate our method on two datasets: common objects in 3D and ShapeNet. These are the metrics used to compare our method with other baselines. Our method shows decent performance when compared to other baselines qualitatively and quantitatively in both datasets. Welcome to our project demos homepage. Here, you will find 10 exciting categories of scenes. On this page, we have the option to choose any scene sequence ID from the drop-down menu. Once selected, we can click the crop button to precisely crop the input images. Here is the final page, displaying the amazing scenes generated from different angles using just 5 input cropped images. By utilizing the slider, we can effortlessly view the scene from various perspectives, and the 3D graph below will automatically update to reflect the corresponding angle position. Thanks for viewing our presentation.